factors. If you want to sum A and B, like A plus B. So when the A is A1, A2, A3, and B is B1, B2, B3, you add them up, then you can have this. This is the addition of vectors. And also it has a scalar multiplication. When you multiply vector A by C, where C is a scalar, then this is a representation of the multiplication. So let's do a quick problem. If we have a vector M, which is I and J, you should know that yes. So this is the addition of vectors. You have a vector M and a vector N. Try to compute the length of the diagonal lines of the parallelogram, whose edge is M and N. So it wants you to compute the length of the diagonal lines. You have to know that the length of a diagonal line is actually a scalar. So what is it that they want you to compute? It's actually the magnitude, right? So it is the magnitude of a vector. So for a parallelogram like this, you have M, you have N. Then how to compute this one? So it's actually M plus N. So this is the vector of this diagonal line, and the magnitude of it is actually you take the norm, right? So then this is your answer. And for M, you can see that M is 1, 1, 0, and N is 0, minus 2, and 1. And then you can add them together. You will have that M and N gives you this. Now also I minus N gives you this. So how to calculate the magnitude? So it's actually 1 square plus minus 1 square plus 1 square, so which give you the square root 3. Yeah, I think that's easy to understand. Also, it's the same for this one, right? And then let's see another problem. Use the vector-based method to prove that a quadrilateral whose diagonal lines bisect each other must be a parallelogram. The diagonal lines bisect. Bisect means that for this ABCD, you can see this is the midpoint of AC and also the midpoint of BD. So that gives you the condition. And then you can see that how do we say that something is a parallelogram? For example, if we have a quadrilateral like ABCD, when you said that vector AD equals vector BC, so that actually means that this is a parallelogram. So if you want to say something is a parallelogram, you just have to prove, you just need to prove AD equals BC, because AD equals BC have two means. The first mean is that they have the same direction. The second thing is that they have the same value. So that actually gives you a parallelogram. And then you can see that if the two diagonal lines bisect each other, that means if you say this point is M, then AM equals MC. They not only have the same value, but also have the same direction. And also BM equals MD. So if you want to prove AD and AD equals BC, then you have to, from these two equations to get this. So how to get an AD? So AD is actually AM plus MD. And also you can see that what is BC? BC is actually BM plus MC. So because you have this equation, you can see that AM and MD equals MC and BM. So that gives you AD equals BC. So that means this is a parallelogram. So if in the exam they want you to prove something is a parallelogram, you just need to prove like AD equals BC or DC equals AB. It's the same thing, right? And then let's see the inner product. Or we can say this is a dot product. For dot product, if like we have two vectors A and B, if A is not 0 and B is not 0, then A dot B, you have this equation where gamma is the angle between A and B. You have to remember that this gamma is in the unit of rad, but not angle, and not degree. So what is rad? Like gamma can be like pi over 2 or pi over 6, like something like that, but not 30 degree or 60 degree or something like that. Okay, I think I need to record this tutorial. Sorry, I forgot. Okay, it starts recording now. And then if like A or B is 0, then the dot product will give you a scalar 0. I think one thing you need to remember is that the A dot B, the dot product between two vectors is a scalar. It is actually scalar. And also if you have A, A1, A2, A3, and B, B1, B2, B3, you represent it in the coordinate form, and then you have this A dot B is A1, B1, A2, B2, and A3, B3. And then is the equation to calculate the gamma, the angle between A and B. So that's actually, this is the equation that you need to remember. It gives you that A dot B over A norm and B norm. So that is how to calculate the cosine gamma. If you want to know how large the gamma is, then gamma is actually arc cosine A. You have this. Also remember that this is in the degree of rad. If they want you to calculate this in degree, you have to turn this into degree. For example, if you have calculated that gamma is pi over 6, then you need to say that this is 30 degree. Okay. And now this is a simple problem. Find the inner product and the length of A and B, as well as the angle between these two vectors. So first thing is to find the inner product. how to calculate inner product. So here you have the equation. You just use this equation. You have A and B. So A dot B has you multiply these three pairs and add them together. Then you have a -1. So you can see this is scalar. You can never get a vector from a dot product. And also the A norm, how to calculate A norm. So A norm is actually A dot A. This is a dot product, and then you square root it. So in this question, you have this A norm is square root 5, and then this B norm is square root 14. And the last thing is to calculate the angle between A and B. So you can see the angle is actually this equation, arc cosine A dot B over A norm B norm. You just put what you have calculated here. Then you can see this is arc cosine this thing. And then this will give you a degree, angle in the unit of rad. Then you have to turn this into in the unit of degree. So how to make this into a degree? You can see that if this is 1.69061 over pi and times 180. So that is actually that is actually how you turn a rad into a degree. You use this equation. Yeah, I think you know this. And then this is something more about inner product. How do we say if you have vector A and vector B, you want to calculate the projection of A onto B. So how do you calculate this projection? It is actually the value of vector A and times this cosine gamma. So that gives you this P. So you can call this a projection. Also, you can see a projection is also a scalar. And and how to if you have like A and B and you want to calculate the projection from A to B, then you have this equation. This is A dot B over B norm. So how do we get this? This is actually from this A norm cosine gamma equals A norm A dot B dot A square A norm B norm. So then you have this equation, right? So that is how you calculate a projection. Sometimes I think maybe you will use this more. So you just memorize it directly, and you don't need to have to memorize this and then you derivative this. So you just memorize this directly. You have P. This is A dot B over B. So if you want to calculate the projection from B to A, so in this diagram, it is like this. We say this is Q. So Q is actually A dot B over A norm, right? And then is something about the inner product. Find the component of A in the direction of B. Component of yes, we can also say a projection from A to B also is also the component of A in the direction of B. In the following cases, you have A and B, so you can just based on the so you just based on this equation, and then you have like P is A dot B over B norm, right? And then it's about something more about vector product. Is the cross product. If we, for example, this is V equals A cross B. And if A or B is 0, then we define V is 0. And you can see that A cross B is actually a vector. So you can see two vectors, the cross product gives you a vector. And a dot product gives you a scalar. So because A cross B is a vector, so it has a norm. So the norm of A cross B. So how to calculate? It is actually A norm times B norm and sine gamma, where gamma is the angle between A and B. And also, this is the norm of V. If we you just want to calculate what V is, the vector V, then you have A cross B, and you need to calculate this determinant. I think you're already familiar with this. Like you have this IJK here, this equation, and how to calculate this one? A2, A3, B2, B3 determinant. This is actually A2, B3 minus A3, B2, right? Then these are some properties of cross product. If something is cross itself, then you have a vector 0. You have to notice that this 0 is actually a vector. So A cross A is 0. Not only itself, but also something like lambda A is 0, where lambda is a scalar. So if A cross something that is parallel to itself with itself, so you have the 0 vector. And then if A is parallel with B, then A cross B is 0. Also, you can say that A is A is lambda times B. Also, if you say this in coordinate form, you have this equation. And here is the calculation of IJK. I think you know that IJK are unit vectors, which means that they have they have the direction of x, y, z, and they have the value of 1. So this is easy to understand, 0, which is the same with this thing. And then I cross j gives you k, and j cross k gives you I, and k cross I gives you j. Yes. And also, if you turn them like you say j cross I, this is actually minus k. So you can see that A cross B equals minus B cross A, right? Then is the problem. For the vector product, V, a vector V equals A cross B, and also you have A and B. Where's the problem? Okay, it just wants you to calculate what is V. So you have this A and B. You just write this in the determinant form. You have I, J, K. Like this is A, 1, 1, 0, and this is B, 3, 0, 0. And then you can say that this is I times 1 plus 1 times 0 minus 0, 0. So then you have this. So you have this. Yeah, I think there's something wrong here. Like because this gives you 1, and this. Oh no, this gives you 0. Sorry, and this is 0, and this is minus 3. Okay, so you can see this is 0, 0, minus 3. And also, assume that vectors M and P are mutually orthogonal, and their norms are M4, N2, and P3. Try to compute M cross N dot P. So you just calculate this step by step. For example, like because you can see that M cross N is a vector, and also P is a vector. The first thing you need to do is to ensure their direction, because they are mutually orthogonal. So M cross N is actually orthogonal to M and also to N, which means that this thing is actually parallel to P. So these two vectors has an angle with which is 0. So you have this. You just do the dot product, this norm and times this norm, and also cosine 0. So then you have this this equation. And next thing is that you need to calculate this. I think you remember that this has the form, which is this. And also, this angle is 90 degrees, or you say it is pi over 2, which means that sine this thing is 1. So M norm, N norm, and this, which actually gives you 8. So you put this here, you have the answer, 24. Yeah, so that is the normal way of calculating this. I think you still need to know that this for M cross N dot P is actually a triple product, right? You can write this like P dot M cross N. So they are the same thing. And also M and N and P are mutually orthogonal. So you can draw a sketch like this. Like this is M, this is N, and this is P. And actually, a triple product is a scalar. And this is scalar that can give you the volume of this. Right? This cubic or long cubic. That this is the the volume. So a triple product is actually the volume of this thing. And then you can see that the value of m is 4, and this is 2, and this is 3. So the answer to this triple product, which is also the volume, is just 4 times 2 times 3. Actually, this is 24, right? So maybe that is the easier way to calculate this problem. Okay. And then it's about a vector field. If you have a vector field like the form like this, then you need to calculate the derivative. So how to calculate derivative? The derivative of this is that you need to calculate derivative of ft, gt, and ht one by one. Then you have this derivative of a vector field. And then it's about a tangent vector. For a tangent vector, you actually have a vector. Actually, a tangent vector is a unit vector. So unit vector, it has a value of 1. So it has a form like this. You need to know that a unit vector have a form like this, right? So a tangent vector is a unit vector. And it also has the form like the tangent of a curve. So that is actually a tangent vector. Then just do a simple practice. Let's see the curve represented by the vector function. And then you need to find this. So you just need to calculate the derivative of this thing, this, and this, right? And then you can have this. So actually, a derivative of a vector field is actually also a vector. You can see here you have I, j, and k. Then you have this equation. The next, find the unit tangent vector to the curve at the point where t is 0. So you can calculate this. It actually, for example, for this thing, the tangent unit vector is right over, you just put this here, over the norm of it. The norm, how to calculate this? The norm is actually you square this and also square the next thing and the third. So you can see this is a function of t. If you want to calculate t0, you just make t equals 0. Then you can get what is t0 is, right? If you calculate this, you can get the answer is this thing. I think this is easy to understand. And then is something about curves and arc length. The length of a curve has an equation like this. If it is a curve from A to B, you want to calculate the length of this curve. You just use this equation. Because you can see that this r prime is dr by dt. and you dot them together. So you can see this is dt square, and also this is dr norm square. And then you square root this. Is actually dr. Right? And then you multiply this by dt. That actually gives you the dr norm. So a dr norm, like for example, this curve, a dr norm is like a very small length, which has the length of dr, and you integrate it from a to b. So that is actually the arc length. So that is how we get this equation. But if you don't know how to derivative this, that's okay. You just need to memorize this equation. This is from A to B. Also, if you want to say that the length of a curve in the form of function of t, like this is from A from B, and at the time of t, at time of t, for example, this is point P, and you want to calculate the length of AP, then you have this equation. You just do the integral from A to time t, okay? Then this is a curve as a function of t. And then it's a problem. For this problem, I will give you 5 minutes or 3 to 5 minutes to think about it. And then I will tell you how to do this. So you can think about it first. Oh, sorry. Yeah, I think it's okay now. Okay, now let me tell you the solution. First, before we solve this problem, you can see that this problem want the area of something. So first I will tell you how to calculate the area. For example, you have a parallelogram, and also this is vector A and vector B. And this is a parallelogram A, B, C, D. So what's the area of this thing? This is actually A cross B norm. So this is the area of this parallelogram. And then if you draw a diagonal line like this, A, B, C, D, then what is the area of this triangle ABD of this thing? This is actually, you can see that is the half of this thing. So this is just, this is also A, B. Half A cross B norm. So if you want to calculate the area of a triangle, and it has like vector M and a vector N, you just write down half M cross N. So that is the area of this triangle. And then if you have like vector A, B, and C, and here like you want to calculate the volume of this thing, which is composed by vector A, B, and C. I think you know that this is the triple product. Or you can write this like the same thing, right? So that is something related to area and volume. And then back to this problem. Like E is the midpoint of BC, and try to prove that the area of the triangle AED equals half of the area of the trapezoid ABCD. So I think that one way to calculate, because now you don't have some equation like how to calculate the area of a trapezoid, right? Like trapezoid. No such equations, but you have equations like how to calculate the area of triangles. So you can start from triangles, and then you have 3 triangles. If you want to say that the area of ADE is the half of area of ABCD, to prove that the triangle ADE equals CDE and ABE. So this is the target. And then you can calculate these 3 things one by one. Okay, first, for simplicity, you can say that BA is vector A, and BE and EC is vector B, and also CD is vector lambda A, because this CD is parallel to BA, right? So you can say that this is lambda A. And then is to calculate the area of ABE. It is half A cross B. And then is the area of CDE, which is, this is B. So it's the half of B cross lambda A. So it doesn't matter if you, the standard way is to write this like minus B, because you can see that if we take the original of C, then the minus B has a direction like this. So the standard way is to write this minus B. But since you have taken norm, so that the minus disappear. And then actually this gives you, you take out the lambda, and also you just take out this minus 1. Then you can get this. It's the area of CDE. And then if you want to calculate the area of AED, you just need to represent what EA is and what ED is. So EA is actually A minus B, right? You have A, you have B, and then A minus B is EA. And also B plus lambda A is actually ED. And then you calculate this. This is actually A cross B lambda A cross A is actually 0, right? So this is 0, and also this is also 0. And you have A cross B minus lambda B cross A. So this is just A cross B plus lambda A cross B. And then you can, from this you can get that this is 1 cross B, right? Then you will get this answer. And then you can have this target. Okay. Yeah, this is the next question. And I think we take a break, take a 10 minutes break, and we shall resume at 15:30. Okay. Let's take a 10 minutes break. Okay, let's continue. For this triangle ABC, if you want to calculate the area of this, actually, no matter you take this, if B is AB and M is BA, so no matter it is BA or AB, and no matter it is B or M, they all represent the area of triangular ABC. But one thing you need to notice that A cross B is not A cross M, right? But if you take the norm, they are equal because M is, this is A cross, M is minus B, right? Which is minus A cross B. So you can see they are not equal, but their norm are equal. So if you want to calculate the area of a triangular, no matter the direction of this is AB or BA, okay. And then for this question, you have a triangular ABC, and the vector BH is orthogonal to AC, and you try to use this B and C to represent this BH. Let's see how to do this. First, you can see that BH is AH minus B, right? You have this triangular, and then you can represent BH here. And then so if you want to calculate the BH, I think the first thing is that you need to find a triangular to represent this BH, because you only get a triangular, and like this is the target. To obtain this target, you have to know these two things to get this target. So the first thing you need to do is to find a triangular. And in this question, you can use triangular AHB. So this is actually the target. And then you already have a B. You just don't know what AH is. So the critical part is to calculate this AH. First thing you need to, I think you remember that for a vector, it not only has a direction, but also has a magnitude. So these are the two things you need to know. First, what is the magnitude of AH? Actually, the magnitude of AH is the projection from B to C, right? So this is B dot C over C norm. And then what is the direction of AH? So the direction of AH, you can use, when I say direction, I actually mean the unit vector of this AH. So this is the direction, or unit vector of AH. So you can see that actually the unit vector of AH is actually also the unit vector of AC, which is C. So this is the direction of AH. And then this is the value of AH. And then you multiply them together. You can get AH. you need to know that this is scalar, and this is a vector. So that is how you get this vector AH. So if it is this representation. So then you have AH, you can calculate BH using this target equation. You have this. Okay, this is how you get BH. And then for this problem, I'll give you 3 minutes to think about it. Okay, for a vector, there's an equation that you need to know. For example, there is in the XYZ coordinate, and there is a vector like P1, P2. Then the angle between P1 and P2 with I, where I is the unit vector of the x-axis. Here you have an angle, and then you have, we say this is gamma 1. Also, you have angle like with J and P1, P2 with K, gamma 2 and gamma 3. One equation you need to know that is cosine gamma 1 square and cosine gamma 2 square and cosine gamma 3 square is actually 1. This is the equation you need to know. And then for this question, actually, you already know the gamma 1 and gamma 2. So it is easy to compute this gamma 3. So you already know gamma 1 and gamma 2. And then if you know the gamma 1, gamma 2, and gamma 3, I think you still remember how do we calculate the angle between two vectors. So the angle, so this is actually arc cosine P1, P2 dot I over P1, P2 norm and I norm, right? And because you already have P1, the thing is that they need you to calculate this P2. So you just say that if you want to say P2 is ABC, then P1 P2 is A minus 1, B, C minus 3, right? And also I is 1, 0, 0, which this is gamma 1, and gamma 1 is pi over 3. So what is the thing that you don't know? It's actually A, B, and C. These three things you want to calculate. So this is the equation, and from these two, you can also get two equations like this. So there are three equations, and then you can calculate what A is, and what B is, and what C is. Okay. So this is the solution. It's actually what I'm saying. For example, here you have not gamma 1, 2, and 3. They use alpha, beta, and gamma. Alpha is pi over 3 and beta pi over 4. You can get this gamma. Also, here is a proof of this equation. You can see this later. Okay. And then these are the three equations that I just talked about. So from these three equations, you have this. So if you say that P2 is X, Y, Z, and then you can calculate what cosine alpha, cosine beta, and cosine gamma is. And then from these three things, you can get X, Y, and Z. So that is P2. You can see this in detail later, okay? And then this is about the derivative of a function, about the chain rule. Here is a way to memorize this chain rule easily. For example, if J is a function of U, V, and W, and also U is function of T, V function of T, and W is function of T. You can also actually draw a sketch like this. So because Z is a function of U, V, W, so you have these three lines. And then because U is a function of T, you have this. And then V is function of T, you have this. W, you have this. So that's the way you can write this down. And from this, if you have J is a function of U, V, and U is a function of X, Y, and V is a function of X, Y. So still you can draw a sketch like this. You have J to U and to V, and also U to X and Y, and also V to X and Y. So if you want to calculate this dz by dx, you just need to go from J to X. So you can see there are actually two ways to go to there. The one way is this, and another way is this. You write down these two ways. This dz by du, dz by du times du by dx is the first way, and then this is the second way. So you can write the equation like this. So that is how you apply the chain rule and how to easily memorize this. And then just do a simple problem. You can see here that you want to compute dz by dt, and z is a function of u, v, and t. And from here, you can see u is also a function of t, and v is also a function of t. So if you want to calculate this dz by dt, so how do you go from z to t? You can see there are three ways. This is path 1, this is path 2, and this is path 3. So path 1 is dz by dt, and path 2 is dz by dv and dv by dt. And path 3 is dz by du and du by dt. So you can easily write down this equation, and you calculate these three things one by one. Okay, so this is the answer. You can see that this is exactly the same with this. And then you can write down the solution, and you calculate this answer. And then for this question, I will give you 2 minutes to think about it. Okay, for this question, you need to see it clearly. He wants you to calculate the unit normal vector, not unit tangent vector. So this is the thing that you need to see clearly. So what is a unit normal vector? Actually, the unit normal vector is the unit tangent vector of the unit tangent vector of this equation. So I can just write down here. If you say the unit UTV, and this is UNV, so the UNV is the UTV of the UTV of a function. Okay, so that is what a unit normal vector is. And back here, first you need to calculate the unit tangent vector. For this, the unit tangent vector, it is just r prime t over r prime t norm. Okay, that is the equation we just talked about. And I think it's easy for you to calculate these two things, which will give you a function of t. like this. And then what a unit normal vector is the unit tangent vector of this thing. Okay, so you still just you know this vector field, and then you calculate the unit tangent vector of this. So it is t prime t prime over t norm prime. So that is what a unit normal vector is. And then when you have this, I think it is also easy for you to calculate this thing. Then you can get this. Here, why the k disappear? Actually, it is plus 0 k. So it is also a vector in the 3D space, but the k is 0. Okay. And then you have this function of t, and he wants you to he wants you to calculate what this is at t when t is pi over 4. You just substitute t equals pi over 4 into this, then you get the answer. Okay, you can see this is the unit normal vector. And then for the next question, again 2 minutes. Okay, this problem wants you to calculate the angle alpha between the curves at the point of their intersection. So if you draw a sketch like this is curve A and curve B, and then here is the angle. So what is this angle? Actually, you need to first calculate the tangent unit vector of curve A, and then the tangent unit vector of B. And the angle between these two vectors is actually alpha, right? So how to calculate the angle between two curves? The first thing, you need to know the unit tangent vectors of two curves. Calculate. And the second thing is to calculate the angle between two vectors. So that's the two step. Okay. And here, actually, the first you need to calculate the tangent vector of this. So R1, so it doesn't matter it is tangent vector or unit tangent vector. So no matter this is unit or not unit, it can they can all represent the direction of this vector, right? So it doesn't need to has to be the unit tangent. So just the tangent vector of this is 1, 2, right? And then the tangent vector of this is 2 times u. And then at their intersection point, you need to know the coordinate of this point, of this intersection point. So how to know the intersection of these two curves is actually you solve this, right? You make this t equals to 2 times u, and also this equals this. And then you can get what t is and what u is. And then you can know at this point what is R2 prime and what is R1 prime. You can get as R1 prime is this and R2 prime is this, right? So here you know the unit the tangent vectors of these two things. And then is to calculate the angle between these two. So angle is arc cosine R1 dot R2 over R1, right? So that is how to calculate the angle. But before you calculate, you can see more, like this is 1, 2, and this is 2, 4. So apparently they are parallel. So you don't need to calculate this. The angle is just 0. Okay. And then is the gradient, divergence, and curl of a vector field. First, you need to know. I think first thing you need to know is the operator. So what this triangular operator is. So it's actually have a form like this. And then I think this is the way that you can easily remember the gradient, divergence, and curl. Actually, when you say the grad f, this is actually right, and the divergence of f is dot f, right, and the curl of f is cross f. And if you see this operator as just you just see this as a vector, like this, and then you can easily calculate these three equations. Like for this one, this is just if f is f x I f y j and f z k, you can easily calculate this vector dot this vector, right? Then you can get the representation of div f. And also, it's also the same for this. So you just calculate the cross between this vector and this vector. And then for this one, you actually know that there's no dot or cross between these two vectors. So for this, how to remember this? You just put f, here. So that is actually the gradient of f. So that's the easy way to memorize these three equations. And so the first thing is the way to remember. And the second thing is that you need to know the gradient of a function is a vector, and the divergence of a function is a scalar. Also, and the curl of a function is a vector. These are the things you need to know. And if you want to calculate the gradient of something, then this something need to be this thing need to be a scalar, right? This is scalar. And then if you write something like this, then this is a vector. And also, you write something like this. This is a vector. Okay, so the gradient of a scalar is a vector, and divergence of vector is scalar, and the curl of a vector is vector. So how to memorize this is actually apparent. If you just see that, if you just think that this is just a vector, so a vector dot a vector is a scalar, and a vector cross a vector is still a vector. And for this gradient, the gradients can also be applied to a scalar, and then which will give you a vector. Because like if you have like a curve, then this is the gradient, right? So it's easy to memorize that this is a vector. So you need to bear these things clearly in mind. Otherwise, when you when you solve the equations, when you solve the problems, maybe you will confuse them. Okay. And so these are the equations. I think you already know these equations. And here is the Laplacian of f. So what is the Laplacian of f? Is this operator dot gradient of f. And before you calculate this, like something like you put a lot of operator here, like something like this. The first thing you need to know is that you need to know what this is. This is a vector or a scalar. You can see that the gradient of f is a vector. And this, you see this as a vector. So a vector dot a vector is a scalar. So when you get the answer, you check if it is a scalar. If it is not a scalar, if it is a vector, then you are wrong. Okay, so you can see this is a scalar. There is no I, J, K. So this is scalar. And how to calculate this? You can just call this step by step. Like this is delta over delta x dx. And then you dot a gradient, and gradient is also vector. And then you dot product these two vectors, you can get this. So if you find it is easy, it is hard to memorize this, you just do a quick calculation like this thing, okay? And then let's just apply these equations. The question is asking that if this is a conservative vector field, what is a conservative vector field? A conservative vector field is equivalent to say that the curl of this is 0. Okay, I think you know that. So the question, so you just need to calculate the curl of this. So what is curl f? You have I, j, k, and you calculate this determinant, and then also here you have x and y. So you apply the chain rule, right? And then you can have an equation like this, the curl of f, which is a vector, but that is not 0. So it is not conservative. And then for the second equation, you do the same calculation. You can see after you calculate it, you can see that this is 0. So this is conservative. Okay. So you need to know what is conservative and what is not conservative. And then this is the next question, is to find the directional derivative of this at a point in the direction of. So the thing is to know what is a directional derivative. So what is a directional derivative? It's actually when you have the gradient of a function, which is a vector. If you want to know the directional derivative of in the direction of vector A, then you just need to calculate the gradient of f, the projection of gradient f on A. Okay. So the first thing is to calculate the projection, the gradient. Is to calculate the gradient, and you know the equation. You can calculate the gradient. This is this thing, and then in the direction of A, you just need to calculate the projection. Okay, because this is a vector, so the projection is actually gradient of f dot A over norm A. Okay, and then you can see this is a function of x, y, and z, and then you substitute this point P, x, y1, z3. You can get the answer. Okay. You can see this more in detail later. And then another question. To calculate, to prove these three equations, where k is a constant vector. Here you can see that this ex, actually ex is I, okay, ey is j, and ez is k. They are the same representation. So this is r equals xi and yj and zk. Okay, and you need to prove these three equations. Yeah, I think there's no time for you to think about it, so I'll just there's no solution, so I'll just write it down. Like first, you need to calculate the divergence of r. So the divergence is delta xi delta y, and you dot product this r. Okay. So you just simply do the dot product. Here, these two give you this, right? Which is scalar, because the dot between two vectors is scalar. And these two things also dot dz by dz, which is 3. So that's the first equation. And then the second is to calculate the curl. So the curl, you just use the determinant, right? I won't write it. The third row is x, y, z, right? And you can calculate and do the determinant. You can get that this is 0. Okay. This is the second thing. And then the third is to calculate this, where k is a constant vector. So you can just assume that k is a, I, and b, j, and c, k, where a, b, c are constant, right? And then you multiply between k and r. And r is this. You multiply these two things, you get ax and by and cz. You need to remember that a, b, c are constant, and x, y, z are some kind of coordinates in the coordinate system. So the gradient of this scalar is actually a vector. So the gradient is and you put this thing here, here, and here, right? You can, if you put this here, you get A. And then put it here, get B. I put it here, you get C. And then you can see this is actually K, right? And then you can prove this equation. You can see this more in detail later. And then the last question is that given this vector field R, also the EX, EY, EZ here are IJK, and the norm of this solid R is a light R, and you know he wants you to prove these 3 equations. So again, you just do step by step, like how to calculate this gradient, the gradient. Okay. I think the thing you need to notice that the gradient of something is this thing need to be a scalar, right? If you want to gradient something, then this something need to be scalar. And then you have a vector. With that in mind, I think you cannot confuse these things. So here you just calculate what R is. So you just calculate the norm of this vector, which is this thing. Here the x prime, y prime, z prime is not a kind of derivative or something like this. It is just, you can see these are just 3 constants. Okay, so in this question, you just see this as constants. And the gradient of R, you have this equation, and you do this here. Then you can get this, okay? Then you can prove the first equation. And the second by the same way, where because the light R, which is the norm of R, is a scalar, and also 1 over R is also scalar. So you can also calculate the gradient of this. So by the same way, you can get the answer like this, right? And then the third way, the third problem, which seems a little confusing. Here you can see the definition of this operator prime. It has a representation of this. So if you use this operator, then x prime, y prime, and z prime are the coordinates, and the normal x, y, z are just constants. Okay. So so it doesn't matter. I think you don't need to know how to calculate this like this, because I don't think you may meet such kind of thing in your exam. The thing that I want to let you to memorize and notice is that how to calculate if the r, the f is if f is a function and f is a function of r. So how to calculate this? So you still do this step by step. So what is the gradient of this thing? Is this? Yes, this you have fr, and fr. And then I think you can solve this problem, because so by this you can actually apply the chain rule. Right? And this you can this is known from the question, right? And also this is something that you don't know, so you just write it here, and then you can get the solution of this, right? So when you try to calculate something like this, you remember to use the chain rule, and don't make yourself confused by what form of this is. So, and one thing that is important is that you need to clearly distinguish what this is. This is a scalar or a vector. So apparently a gradient of something is, this thing actually must be a scalar. And the answer is a vector. So with this knowledge, I think you can solve all kinds of questions like this. So I think that is the end of the tutorial. And thank you for joining. If you still have some question, I can, yes, you can find this PowerPoint on the portal. If you don't have any question, you can leave. Thank you, and hope you can do a good job in the midterm test. So what is the vector on page 43? I don't know which vector are you saying. You're saying this? What is vector on page 43? Yes. So that is the important thing, because he wants you to, you can see it from here. It is a gradient of something. And I said that this something needs to be a scalar, right? So this FR is a scalar. So that's the message you need to get from the question. So if you gradient something, then this is a scalar. And if you like the divergence of something, then you need to you know this is a vector. And sometimes the question will not tell you whether this is scalar or vector. You have to get this message yourself. Okay, and also the curl of something, then this is also a vector, right? Yeah, it's okay. So it seems like no more questions. Then I'm leaving. Goodbye.